Alright, I'm looking at number 22 here. And this one, if I look at the answers, I can kind of see what the questions pertain to. So the first one here, this looks like the average value of the function from 6 all the way up to 9. And then you got the 1 over 9 minus 6 out front, the 1/3 out front. So this is really saying the average value of the function would equal that. This here looks like kind of like a slope to me, but it's the slope of the derivative, so that's kind of what that one's pertaining to. And this here is saying that the function is decreasing, f of x decreasing. So there's some like clues on what's going on. And I feel like it might be the first one because that's what we did in one of the sections, but I really don't know. I'm going to read the question quick. So it says the function f is continuous for all real numbers and the average rate of change. Okay, average rate of change is not the same as average value. And I feel like I even had this wrong in the key at one point in time. So let me check here because I want to make sure it is wrong in the key that I say that. Yeah, I definitely have this wrong in the key because the average rate of change is not the average value of a function. It should not be that one. Okay, let's see here on the closed interval. From 6 to 9, there is no value of c such that the slope is equal to -3/2. So from, it's continuous, and we're going from here to here. And it's telling us that there, at no spot is there a slope that's equal to -3/2. So up 3 over 2 would be something like that. Okay, of the following which must be true. So it's definitely not this one. It's decreasing. See. Okay, it tells us the average rate of change, so the slope is -3/2. So that would mean that it starts somewhere and it ends somewhere, and if I did a secant line from here to here, it would have a slope of -3/2. But it says there's no value of c where the slope is equivalent to that. And if we remember the mean value theorem says if the slope from here to here is something, and we have a continuous and differentiable function, there has to be another spot where the slope is equivalent to that. But it's saying here that it's not equivalent to that. And we know that the function is continuous for all real numbers, so therefore it must not be differentiable everywhere. There must be like a corner in the graph or something like that. So f is not differentiable, because if it was, we would end up with the average rate of change equaling the slope at some spot. So this is the mean value theorem, which is back to a lesson before. Okay, this is not the correct answer, even though that's what the key says. I am sure that I made that incorrectly at one point and never fixed it. Okay, if we're looking at 25, there's two ways to do 25. There's an easy way to do 25, which we haven't learned, and then there's a more difficult way to do 25, which is how I'm going to show you right now. After this test, I can show you an easier way to go about doing it. But right now, we're trying to find dy du, which means we're taking the derivative of y with respect to u. So right now we've got y, and over here I want to put u's so that I can take the derivative with respect to u. And right now I've got x's. So if I take this here and I solve it to get x by itself, so let me do that here. So I've got u minus 1 equals 2x, divide everything by 2, and I've got x equals a half u minus a half. And I'm going to plug that in wherever I see an x here. So I've got y equals a half u minus a half squared, and then minus 2x would be minus 2 times that. The nice thing about this is I can distribute this through and it simplifies, and I'm just going to leave this as squared because I can use the chain rule and it's easier than foiling that all out. Okay, if I distribute here, I get minus u plus 1. Then I'm going to take the derivative of y with respect to u now. I pull the 2 down, I leave the inside alone. It's raised to the first, then I times by the derivative of the inside, which would be timesing by a half. These will cancel. Then the minus u is going to turn into a minus 1, the plus 1 goes to 0, so it's gone. So all I have left is 1/2 u minus a half minus 1, which is the same as 1/2 u minus 3/2. And then if I go and look at my answers, they're in terms of x, so we got to plug this back in for u. So we have 1/2, and instead of u, 2x plus 1. And then we got a minus 3/2 out back. Distribute, we get x plus a half minus 3/2, so that's going to be x minus 1. Alright, and then one more question here in 5, part A. And let me read your question a little more carefully here. The 10 turns to a negative, so we're looking at the first part here. Okay, so I'm looking at this part here. If I'm finding g of negative 6, then I would be going from negative 2 to negative 6. But we know negative 6 is smaller than negative 2, so what I'm going to do is I'm going to flip my integral, and when you flip your integral, you change the sign. So it's positive right now, we're going to change it to a negative. And then I want to find this here, which is just our area. And remember, if it's below the x-axis, we treat it as a negative, and if it's above, we treat it as a positive. So we got the negative that's sitting out front here, and then we're going to figure out what the area is from negative 6 to negative 2. And it's above the axis, so it's positive, and it's area of a triangle, so we do 1/2 base times height. And our base goes from here to here, which is 4, and our height would be the y value of 5. So we end up with this negative sitting out front because we had flipped that integral around. And then we just end up with 10, so negative 10.